Next up, we have Heuristic Tecpetrol, and they're going to talk about how they use simulation and optimization of sand supply in fracking operations. Please welcome Damian Marino and Chiara Dolce.
Thank you, John. And welcome, everyone. Today, we are going to be sharing with you a simulation application we developed for planning fracking operations. During the presentation, we're going to be talking about which the stakeholders are of this project. Then we're going to quickly touch over what are the important things you need to know in order to understand what are we modeling in our system, and also why this project is so relevant. After that, we are going to show you, of course, the model, but more importantly, how it has been used since implementation. It was around March 2022. And lastly, we're going to finish with the results and actually some figures of the savings that the company have by implementing this tool. So first, the first stakeholder is Heuristic, which is the company that developed this application. In Heuristic, we are a company that strives to help our clients to approach to the most advanced analytic methods. And for doing that, we develop software, but we also offer consulting services supporting into modeling, simulation, optimization algorithms, and machine learning. And since most of the application we developed are tailor-made, we get to choose the best approach for each problem we have to solve. In this occasion and for this project, we work with Tecpetrol. Tecpetrol is an oil and gas company, an Argentinian oil and gas company that specializes in production, exploration, distribution, and transportation. And today is one of the main operators in one of the largest um, shale gas reservoirs in the country. Yes, excuse me. I'm gonna hide this pop-up. Um, Now, in this reservoir is producing over 1,000 fracking stages per month. And today we're very pleased and happy to have Chiara with us. She's the supply chain specialist and the product owner at Tecpetrol. And she will be sharing with you all the details you need to know about the operation and why the project is relevant for the company.
Thank you, Damian, for the introduction. To explain what we were looking to solve, I must first quickly touch into what fracking is, how the sites operate, mainly what happened in the surface, the main logics and the dynamics of the system, to finally understand what was the need. For those who never heard of fracking before, this is a simplified version. When oil and gas is trapped in a shale reserve, one way to extract is by crushing the source rock using a mixture of water and sand at a high pressure. This creates cracks from which the gas can escape. What is very relevant for this project is that the contractors and the equipment that perform this task are very expensive, and the objective is to avoid idle time. In this walkthrough of the process, we can identify two different locations: the sand warehouse and the pad or site that holds the operation of fracking. The sand is transported by trucks using hoppers or containers. Once the trucks are loaded in the warehouse, they travel to the pad, usually through road terrain, for up to 150 kilometers. Once the trucks arrive, they wait to unload the cargo and load an empty container. In the location, there is a forklift that moves the boxes to supply the platforms, manage the stocks, and serve the trucks. Finally, the trucks travel back to the warehouse that can supply the type of sand, and the cycle starts again. After this quick overview, we need to understand that there are many complex decisions. One of them is to quickly serve the trucks so they can maintain a constant supply of sand at the minimal cost, but without affecting the service level at the platforms. Also, the stock in the site needs to be balanced to, to supply the sand type that is required at any time. And some empty containers need to be available to speed up and turn around of the trucks. Lastly, there is a key player in our system and is the forklift. This resource has many duties. It must constantly arrange the containers in the best way possible to absorb anomalies in the system in case something goes wrong. It must avoid unnecessary movements and be ready when needed. It must keep an eye on the stock, the trucks, and the platforms to make decisions. In a complex system like this, we were doing all the analysis in a static fashion using Excel to make decisions. This was not enough to answer the questions such as how many trucks and containers are required to operate, which arrangement has the best performance, what is the production we can achieve with our existing logistic network, and some other questions, what if that you can do. So all these questions were not possible to answer and were fundamental for us to be more efficient. That is why we approach heuristic.
Yes, and that's when we realized that there was a great opportunity for us to work together in building a model to represent all these resources and how they interact each other, with the purpose in mind to first answer all those questions and also make it flexible enough to try other configurations that they were also interested in. For doing that, we chose AnyLogic for several reasons, but I'm gonna highlight at least three that for me are the more relevant in this case. The first one, we in heuristic we have vast experience with AnyLogic for more than 4 years, and we prove time after time that for these kind of scenarios where there are complex systems with time-dependent decisions, AnyLogic deals very well. The second one is that AnyLogic is very good with giving you the opportunity to tune easily the user interface and give the user the answer from the model very quickly and adapt it to show what's actually important and relevant. And lastly, that's very important for this particular project, and maybe, is that AnyLogic has a unique feature of being so friendly to multiple iterations and multiple simulations at the same time. That is what we are looking for. For example, in this case, that we're trying to test different combinations and get the best trucks and best containers that can provide in this system. Just right now getting into what the model was, what the model actually is, because it's running right now. And so we have the digital representation of the logistic network. It takes input from an Excel file that is downloaded from the Tecpetrol database. It also collects information from the user interface through a user configuration panel, and that configures two experiments. One is the simulation experiment, and the other one is the parameter variation experiment. Both talks through the model, one single model that is codified through agents and discrete events to maximize the performance. All that information that the model creates is either exported to another Excel file or, more importantly, just quickly shown to the user through the user interface. Now, I'm going to explain why we have two different experiments in this case. And I'm going to show you exactly how the user uses this application. First, they run a parameter variation, which is basically experimentation of different combination of trucks and containers for one specific site. And this is how the user interface looks like. This is the first control panel that the user sees. So going into how the user uses it is to select one site from the upper box. One of those sites is an Excel file with all the configuration and all the details about the pad itself. And the user can choose from running multiple combinations for each of the, multiple iterations from each of the combinations they're trying to achieve. In this case, I'm setting from 8 to 12 tracks and using 30, 40, and 50 containers. There's also a quick opportunity to click or unclick the induced failures of the system, but in this case, we're unclicking them for demonstration purposes. And it tells you that it has 15 combinations. It's going to last for maybe 20 minutes, but don't worry, it's going to be in fast forward. And this is the analysis being done. What we see in the very left of the screen is the list of scenarios, the combination of 8 tracks with 30 containers and so on. And at the left of them, there's a little dot that changes color. And that color is very important. What the users usually do is check the boundary when the color changes from red to green, because red means that that particular combination is inducing problems in the operation. That means that the quantity of trucks and containers are not enough to maintain a constant supply of sand. Whereas the first scenario with 10 trucks and 50 containers is enough to don't produce any non-productive time in the site. Here, most of the KPIs are histograms because we have multiple iterations for each of these scenarios we are picking. The next step the user will normally take is, okay, now we have an opportunity to test 10 trucks and 50 containers and go in detail and see how the scenario performs. So now we are jumping into why there's another experiment called simulation experiment. And it is because it has less parameters to set, but it's enough to be feedback from the parameter variation. And in this case, I'm going to show you that I'm going to select, again, site number 1, and I'm going to pick 10 tracks and 50 container, which was the combination that was optimal from the parameter variation. In order to get the same results, I'm going to unclick the failures. That's basically to get the results that are easier to understand in the presentation. This is only one simulation, and that's why it's very quick, and there's no need to make it fast forward. And there are 2 panels with information, so we can start here answering more questions than just only how many trucks and how many containers. I'm going to quickly run through what this simulation is showing us. In this section, what it's showing is that at any point of the evolution in time with the stages, we have at least 2 stages of stock to keep on going. Maybe this is telling us that there are maybe a few boxes more than we actually need, so we can reduce that and maybe try 10 track with 45 containers. Here we can see that, but instant by instant, and that's why at the very end you have no stock, because that's the main purpose of the simulation, just to finish with the sand you provide to the site. Then you can monitor the production, and we can see that the production oscillates because most of the system has variability in it. We can see a snapshot of the different categories in which the pad and the track evolves. For example, for the tracks, you can see a big chunk of the pie that is the tracks are traveling, or waiting in the warehouse, or serving in the pad, and little time is a waste, so it's just wasting time. And non-productive time, we can't see any because we actually picked one scenario that was in green, but if we would have picked another one in red, we would have seen non-productive time generated with the different categories. The other view gave us different information to complement that one, and we can see the utilization of the forklift to understand if it was a bottleneck or not. In this case, it wasn't. We can also monitor the waiting time of the trucks, again with a histogram, and see details of where the sand is provided in this case, because as Chiara mentioned, there are many warehouses that can provide the sand to the site. But most importantly, there's a KPI in the right that says trips with cross-docking. What does it mean? Cross-docking are those very efficient movements that the intelligence of the forklift is able to perform when certain conditions can happen. So that is picking straight away from the truck the container and putting straight away to the platform and vice versa. That allows the system to avoid another inefficient movement, which is going from the truck to the stock and to the stock to the platform. And lastly, we can see day by day how many trucks we were using. If this information is not enough to collect all the data that the user needs to take a decision, you can download the information and maybe use it in the future to compare with another scenario. And now, with all this, maybe you're wondering what's the value of having this tool and how it impacted Tecpetrol.
Well, in Tecpetrol, we have been used this app for the last 8 months, and now we can summarize the impact of 4 valuable results. The first result is the reduction of non-production time with an estimated saving of $500,000. This means we deliver the sand without affecting the operations since the deployment. The second is to be able to compare technologies and even use it to negotiate transport contracts. Third, and very important, is to assess what is our bottleneck and where it moves when, for instance, we choose a different contractor or we have a site far from the sand warehouse. And lastly, we have now a flexible tool that was being used to evaluate a new design of platforms and containers. We are talking about investment of around $3 million that can be backed up with a solid statistic analysis. I hope you find interesting. Thank you for your time, and we are happy to answer any questions you may have.
Thank you very much. We already have some questions. Let me read out loud the first one. So it says, a few seconds ago, do you use the Monte Carlo experiment or do you have a panel and use custom experiments on the background? Actually, that's what we do. It's not a Monte Carlo experiment, it's a custom experiment. And the fact that probably you read Monte Carlo in the screen is because for each scenario, it's actually a Monte Carlo. And that's what we use that wording. But no, we are not using a Monte Carlo experiment. And then the other question says, how do you determine the type of simulation
you have employed?
I don't think I'm getting the point of the question. The type of simulation. You mean which one the user would pick to answer the certain questions? Well, mainly the parameter variation is used when you want to determine the number of trucks and containers you want to use. So you narrow it down with the parameter variation. Then when you want to explore a specific scenario and see more detail, that's when you go to the simulation. And how long did it take to develop the tool? Well, we started in December 2021 with the idea. Took a lot to collect not only the data, but to understand the decisions that the forklift made. Maybe you, Chiara, want to clarify which parts of the project took more time?
Excuse me?
I thought you want to clarify this part of the questions.
No problem.
Yeah, but it took from December to the end of February. So we implemented the tool in March, probably the final tool. But usually what we do in heuristic is make it short deliverables. The first one was in 2 weeks, just to get the feel of what we were progressing with. And it's still the first deliverable gave value to the company. And the validation of the results, that's very important in all the simulation. And probably we spend a lot of time, maybe same time as the development, testing. Yes, yeah. Yes, the validation was extensive, and part of why we have so much flow of information is because we wanted to make sure that validated the real life. And in real life, Miguel can explain that they have a control panel of each of the paths. So we use past data to verify what would have happened if we would have used the simulator in that scenario. Um, Maybe Miguel, you can answer that one. How frequently do you use the application?
Well, we use it every time we are going to start with a new path, with a new situation. So, like 2 weeks before, we start with all this simulation to get how many tracks we need for this operation. And we speak with the contract to be agree in that task.
Are you planning on any extension of the model? Yes, actually, this model was the first full release, and after that, we have two modifications. The first one was implementing a complete different contractor that wasn't using containers and hoppers. It was using silos and another means of transport. So the logics inside the pod were slightly different. We have to adapt it. And the latest extension of the model was to include another parameter variation. So instead of changing trucks and containers, what you do is you set the trucks and containers, because we already know that from this parameter variation, and you stress the model with different production rates. So, okay, the last question is, if you are using experiment custom, then how are you enabling the UI? Oh, in this case, we use the parameter variation experiment, but we set it programmatically, if that answers your question. You get a chance to compare the other output with. Do you get a chance to compare your overall output result with any previous available existing data? That's
Yes,
actually
we reduce the known production time with this simulation, with this program.
Yeah, that was actually the core of the validation, using all the data Tecpetrol had about existing and previous paths and how they perform. So we're trying to set that in the simulation, running with the simulation and also with the Monte Carlo, and comparing all the data. Another extension we are planning on the model is putting the simulator online, because in the company they sometimes there's a group of employees that want to put their hands on the simulation, and being online is a good advantage for them. Is there any other question, or maybe we missed it? And does the application take data from the operations in real time? No, at the moment it's not a digital twin. We thought of the option of making it a digital twin, but the ecosystem of Tecpetrol is not able to capture the data in real time, so that is not an option. But the input that is captured from Tecpetrol database and is a picture of what happened at that moment, but we cannot get the evolution of that. Okay, I think there's no more questions. Thank you very much.
Thank you.
Thank you.
Thank you guys so much. We all appreciate that.